Welcome to another nostalgic math chat. We are rambling today about the department's May 2023 paper 2 question 5.5, a trig equation question. Awesome. So we are given 3 times tan of 4x is equal to negative 2 cos of 4x, and you're asked to show without using a calculator that sine of 4x is equal to negative a half as being the only solution to the above equation. Oh, wow, interesting. Okay, so let's see. Thank you for the heads up. Right, so question 5.5.1. So we have an equation where on the one hand we're talking in terms of tan, and on the other hand we're talking in terms of cos. So that immediately makes me think about the identity that says tan theta is just the same as sine theta divided by cos theta for most values of theta. Okay, of course, not for the values where tan is undefined, so like your 90 or your 270 or your negative 90, etc. Okay, so that makes me want to express the tan as sine 4x over cos 4x is equal to negative 2 cos 4x. Okay. Then from there, I'm just going to rewrite this as 3 times sine 4x divided by cos of 4x is equal to negative 2 cos 4x. Okay, so what we can do then is times both sides by cos 4x. Yeah, that's fine. Times by cos 4x. Okay, so then we have 3 sine 4x is equal to negative 2 cos squared 4x. Okay, right. So now we either want to have the equation only talking in terms of cos or talking only in terms of sine. And I think it is probably easier to get the equation to talk in terms of sine, because if I look at this side, sine of 4x, what are my options to get it into cos? I could use co-ratios, but then we're going to be talking in terms of 90 minus 4x. The double angle identity of sine also just results in a term that talks in sines and coses. Whereas if I look at the cos over here, right, cos squared 4x, I could rewrite in terms of the squares identity, right? So we know that sine squared of an angle plus cos squared of an angle is equal to 1. So I could rewrite that as cos squared theta is equal to 1 minus sine squared theta. And I think they do give this to you on your formula sheet. Okay, so I could rewrite that as minus 2 times 1 minus sine squared 4x. Right, so that's 3 sine 4x. Okay, so again, 3 sine 4x is minus 2 plus 2 sine squared 4x. Okay, so this is a quadratic equation. So instinctively, intuitively, I want to make one side 0. Then we're going to have 2 sine squared 4x minus 3 sine 4x minus 2. Okay, so you could solve this using the quadratic formula, or you could just attempt to factorize it yourself. I will go with the latter. Okay, so I know that my first terms will be 2 sine 4x and sine 4x. because that's the only way I can get 2 sine squared 4x. And then my last terms are either going to be plus 2 minus 1 or minus 1 plus 2, or jiggle them around. And how do we figure out which one works? Okay, so I'm just going to list my options here. So either this could be a plus 1 minus 2, or it could be a minus 1 plus 2, or the plus 2 could be here, and the minus 1 could be here, or the minus 2 could be here, and the plus 1 would be there. Okay, so let's see. If I say 2 times minus 2, so that's minus 4, and then 1 times that, so minus 4 plus 1 is minus 3. Ha! I was lucky on the first try. So this is the combination that works, okay? Because 2 times minus 2, so I'm going to get minus 4 sine 4x, and then sine 4x times positive 1 is 1 sine 4x, which gives me the middle term I want, minus 3 sine 4x. Awesome potatoes, awesome potatoes, the potatoes are so awesome. Awesome, awesome potatoes, the potatoes are so awesome. Right. Okay, cool. So now that we're all factorized and happy, that means 2 sine 4x minus 1 is equal to 0, or sine 4x minus 2 is equal to 0. Okay, so then, okay, maybe let's just shrink all the stuff that has happened so far. Oh, 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 bracket, took my bracket. This is always so tricky. I need to learn how to write straight. Just going to align that. Okay, then remove this guy up. Okay, so that means sine 4x is indeed equal to, oh, that was a plus 1. Oh, okay, so that will be minus 1 over 2, or negative a half. So that's just if you rearrange. Okay, I always pride myself in going slowly, and then I do things like this. So minus 1 on both sides. 2 sine 4x is equal to minus 1. Divide by 2 on both sides. So sine 4x would be equal to negative a half. Okay, or the other option would be if sine 4x is equal to 2. But that is impossible, okay, because we know that sine of any angle will always be between negative 1 and positive 1. Okay, so this is the only valid solution, as the question told us. Sine of 4x is equal to negative a half is the only solution to that equation. Okay, so then we're asked to determine the general solution of x in that equation, in the equation that we started out with. So we have managed to break our equation down to something simpler. All we need to solve is that, and then we will have solved the original equation. So let's do that. Sine 4x is equal to negative a half. Okay, so if we know our special angles well, that wasn't necessary. If we know our special angles well, we know that sine of 30 degrees is equal to a half. Okay, or if we don't know our special angles too well, we will start by finding the ref angle, right? Which positive acute angle has a sine ratio of a half, right? And we know that for our positive acute angles, the ratios are only positive. So we're not going to put the negative into the calculator. We're just going to put positive a half. So we're going to find the inverse of sine for the ratio of a half. Which positive acute angle does this sine ratio belong to? So we shall say, right, and we get 30 as our answer. Okay, so that means our ref angle is 30 degrees. Okay, next thing we need to think about as well, okay, in which quadrants, right, do we find angles that have a negative sine ratio? So if we look at our quadrants and we look at our cast diagram, we know that the angles that have a negative sine ratio are these guys and these guys. Okay, so third and fourth quadrant. So our third quadrant angles we will express as 180 degrees plus 30 degrees plus however many revolutions you want to add or take away, right? Because then you always end up in the same place in the third quadrant. Okay, or the alternative is our fourth quadrant angles, which will be 360 degrees minus 30 degrees plus k 360. Okay, where k is some integer. Okay, so let's write that formally. So we have 4x, okay, because that's the angle we're dealing with over here. So it's either 4x is equal to 180 plus 30 is 210 degrees plus however many revolutions you want, or it will be 4x is equal to 360 minus 30 is 330 degrees plus k 360. Okay, then somewhere just write what k is. Right? So k is some integer somewhere. Okay, right, so let's first deal with this side. So in order to just get x, we're going to divide both sides by 4. Okay, so that'll be x is equal to, I think that is 52.5 degrees plus k 90. Okay, so remember to divide that as well. Or, again, divide both sides by 4. Okay, so that'll be x is equal to 330 divided by 4 is 82.5 plus k 90. Okay, and those would be your two possibilities. Right, let's see if the memo agrees with us. Very important for us to be in accord. Okay, so the first one we showed successfully, and then for the second one, indeed, our answers are in agreement.